Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming. Hello, and a very good morning to you, and you're welcome to today's Signpost webinar. And today we'll be discussing the drainage status, quite aptly, and the management of peat grasslands in Ireland, which is a key issue that relates to land use, climate policy, and rural development. As we know, the Climate Action Plan identifies re-wetting and improved management of peatlands as key measures for meeting national emissions targets and contributing to climate neutrality by 2050. And today we're delighted to be joined by Dr. Patrick Tuohy, who's a senior research officer based in Moore Park, working in the area of soil hydrology. Pat, good morning to you. You're very welcome.
Morning, Mark. Thank you. Morning, everyone.
And Pat, we're also joined by Cathal Summers. Cathal, you're going to help out with questions a little later on. So Pat, before we maybe get into the slides, could you just tell us a little bit about the work that you're doing there in Moore Park in this whole area?
Yeah, so as I said, I'm based out in Moore Park, but there isn't a lot of peat soils in that part of the country, so we tend to move into other areas of the country. But look, we've a long number of years on projects in this space, and there will continue to be a lot of project work in this space, and it's becoming, I suppose, a topic that's of more and more interest all the time, given various different policy positions now in terms of emissions and so on, and the status of these soils. I hope I'll try and to make clear over the next half an hour, 40 minutes, in terms of where they sit in the grand scheme of the emissions targets and the Climate Action Plan and so on, and how we're looking, I suppose, in the research side of the house to answer fill in as much of the knowledge gaps as we can and answer as many questions as we can around some of the uncertainties that are there around the management of this group of soils or this land. So yeah, I'd like to first of all, I suppose, acknowledge my other colleagues and partners within Teagasc and within NUIG, in particular the University of Galway as it is now, and other projects that are listed there that I'll be mentioning as we move through, and that some of the data we have here is coming from lots of interest, as I said, in this space, and lots of projects in this space. In terms of background or context for the topic area, peat, as we know, is an accumulation of partially decomposed organic matter. High rainfall and impeded drainage is in play. So waterlogging or saturation is the key issue. And for a peat to form, you need saturated conditions, and that's why I suppose the drainage of these soils, where saturation is reduced or the degree of saturation is reduced, is an issue in terms of how these are managed. That build-up of organic material is a huge store of carbon. Nationally, there's about 1.5 million hectares of peat soils in the country, so 21% of the land area. So you could take it as 1 in every 5 hectares is peat. So quite a significant amount by any measure. In the grand scheme of things, we're not a huge country by area. There's much larger banks of peats out in some of the larger countries, but as a proportion of the total area, ourselves and the Scots maybe and the Estonians or the Finns would be in that league. But, as a proportion of the total area, we're fairly high up on that league table, particularly in a European context. That accumulated carbon, as I said, or that accumulated organic material stores, it's been estimated 2.3 billion tons of carbon. So, figures that are hard to wrap your head around, really huge volumes of carbon in that 1.5 million hectares. I'm speaking today, and I suppose my focus area in most of the research work that I'll be talking about is looking at the grassland peat soils. So it's important to recognise that 1.5 million hectares is not all under the remit of agriculture. The pie chart there on the left is from David Wilson, a 2021 study, estimating that the agricultural proportion of the peat soils is about 28%. You can see there in the other sections of the pie chart, there's natural peats, there's a forested peats, cut over, industrial cutaway, and so on. So there's different land uses that fall under that 1.5 million hectares. So as I said, it's not all under the remit of agriculture. If we look at the map on the right, and John Connolly was here in my position a few weeks ago, so this is an output of John and one of his colleagues in terms of a map, and there's a number of different maps being produced over the last number of years, or over a long number of years. But again, it's just to get that idea of where these peats are. If 1 in every 5 hectares is peat, there's obviously quite a selection of them to choose from in terms of locations, but predominantly the western seaboard and the Midlands. If you move towards the south coast or the east coast, unless you're in areas of high ground, you can pick out the the Wicklow Mountains or the Galtee Mountains there, and certain depending on the regions you're familiar with, but largely Midlands and Western Seaboard, but scattered quite broadly around the country. If we look then in terms of the numbers and the emissions, just to remind people again of some of the figures that we're working on or basing our work on. If you look at the grasslands category in the National Emissions Inventory Report, which is a report produced every year by the EPA, estimating or accounting for all the emissions from the national emissions, so including everything, including transport and energy and so on, and you're familiar with that or broadly familiar with that, I would think. Under the grasslands category, under the land use heading, there's approximately 3.9 million hectares of grassland on mineral soils and about 339,000 hectares of grasslands on peat soils. And those peat soils are responsible for quite large emissions, as we'll see in the next few slides. And the management of those peat soils then comes into play in terms of trying to reduce those emissions. The other categorization, I suppose, that's important is the drainage status. And this is something we've been working on, putting a lot of work into, I suppose, over the last few years, is that the emissions or the drainage status and associated emissions from peat soils is based on water table depth. And there's two broad categories which are recognized. What's classed as drained is a peat soil where the average annual water table depth is greater than 30 centimeters below the surface. And what's classed as re-wetted is where the average annual water table is less than 30 centimeters below the surface. So those two categories have very different emissions profiles and very different total emissions. In the last number of years, as I said, we've been digging into this and trying to, I suppose, put more, add more detail, I suppose, in terms of the inventory and in terms of how these soils are being assessed. This time last year, there was an update to the National Emissions Inventory, which we had a hand in, as I'll go through in the next few slides. So this prior to that, or pre-2024, you had this scenario where there was an estimate of these emissions were estimated from grassland peat soils to be at 9 million tons of CO2 equivalent per year. That was based on the total area, the extent of the peat, the drainage status, as I've highlighted in the red, which was the major, I suppose, element that dictates the emissions, the land use, the nutrient status, and emission factors. But combination, or looking at the combination of those factors, was yielding a total emission estimate of 9 million tons. The area, as I said, is 339,000 hectares, and all of that was assumed to be drained, which was, I suppose, an assumption that we started to question at that time, because there was a view taken that was a fairly simplistic assumption. All those elements, and as I'll go through in the slides, all those elements around that bubble are subject to ongoing research. But the drainage status is one that I suppose concerns me most, or concerns the group that I'm working with most. As I said, we questioned that assumption and we challenged that assumption in 2023 with this publication, which was published in the summer of 2023, looking at the drainage status of grassland peat soils in Ireland. And with that, and I suppose related work, our core question really was how much grassland peat is effectively drained. And when we talk about drainage, it's not the presence or absence of, open drains or infield drains or drainage features that we'd all be familiar with. It's about water table control from the hydrology point of view. Where is the water table? And that's why I highlighted earlier in the National Inventory Report, it's very clear the water table is the key parameter that these emissions are gauged off, above or below 30 centimeters on average throughout the year. If everything is assumed to be below 30 centimeters and drained, that imposes a certain level of emissions. But how realistic is that assumption is what we were questioning, and is the water table maintained at that level on all 340,000 hectares, for the sake of round numbers, over the course of the year? The key arguments we made, I suppose, that drainage of peats is technically difficult and expensive. There needs to be a very high level of investment, and ongoing investment required to effectively control the water table at that greater than 30 centimeter level. Without maintenance, so there's initial capital investment and there's ongoing maintenance. Without maintenance, the functionality of the drainage systems reduces over time. And ultimately, we argued it's not feasible that all grassland peats fit under those categories, that there was a high level of investment initially, very intensive drainage systems installed and continuously maintained, since installation. It just wasn't justifiable. Ultimately, that argument was accepted, as I said, that publication in 2023 and a lot of follow-up work. And by this time last year, that argument had been accepted. So we went from a position on the left where, and I've moved around numbers here, as I said, instead of 339, I'm talking about 340, but for the sake of the argument. But we moved from a position where 340, all of it was considered to be in that drain category, and none of it was considered to be in the rewetted category, which yielded an emission, estimated emissions of 9 million tons of CO2 equivalent, to the current position, or the updated position since this time last year, and which is carried through, that only 140, I shouldn't say only, but of a proportion of those, the proportion of those that's drained is 140,000 hectares, and the balance then the 200,000 hectares. And they're not exactly those figures. You'll give me a bit of leeway around the rounding of those numbers, but approximately 200,000 hectares are classified as rewetted, with resulting total emissions now of 3.9 million tons, which is still, a very high level of emissions. And still, a problem in terms of something that has to be dealt with, and a level of emissions that we need to reduce and need to mitigate against. But I suppose from a policy point of view, it has changed the starting point in terms of the management of these soils. So again, to keep blowing on this point, but 200 of the 340,000 hectares, which is just shy of 60%, are now classified as rewetted, with a water table on average throughout the year less than 30 centimetres. This, for me, I suppose, in terms of the policy or the take-home messages going forward, is the important slide I'm going to show today. I'm often speaking about this topic and related topics, and the hands will always go up, or the questions will always come. What is rewetting going to look like? And there's currently, if we take the Bord na Móna are responsible for 80,000 hectares of industrial cut over peat. They've committed to rewetting a large proportion of that. I think it's 33,000 hectares in the medium term. About 14 or 15,000 of hectares of that is already done. I stand to be corrected in those figures, but that's my understanding. And the rewetting of those types of peats is, bringing the water table above the surface, creating ponds, creating flooding on the surface. And maybe that's the reference that people have when they hear about rewetting. That is not at all what's suggested or what's planned in terms of water table management on grassland peat soils. And when I'm asked the question, what will rewetting look like? Is the land going to be flooded? Is the farm going to be flooded? What's the use of it thereafter? We can now very clearly say, and it's recognized, these are classifications. 60%, 6 out of every 10 hectares of this land use that we're already dealing with is already classified as rewetting. So, you tell me what it looks like. This is the current use case for the majority of the peat grasslands in the country. And if you take it that these are, the current spring, we're after a relatively dry spring, but this time last year we were after a lot of, long months of heavy rain. But in most winters, the water table on these soils will be at or close to the surface. And in the summertime, it'll be much reduced. It'll be down to 30, 40, 50 centimetres for, 4 or 5 months of the year. So on average, where, summer grazing might be the use case, or the management as was will continue on, it's still quite possible that that's in the average water table position is less than 30 centimetres, and it's already, as I said, in the rewetted, or classed as rewetted. So it's important, I suppose, to state that. And rewetting, as I said, doesn't mean flooding or bringing the water table above the surface. So the outlook, I suppose, from that being the recognised starting point, or point where we're at with these soils in terms of drainage status, and we've more work to do to try and refine that further. Plans to further reduce those emissions will rely on manipulating the water table by raising the water table, removing and blocking existing drainage features. Excuse me. In the Climate Action Plan, such works are proposed for 80,000 hectares of drain peat grasslands. But the way we see it, I suppose, in terms of the work that's going on, or the research work that's going on now, is to try and, as I said earlier, fill the gaps in some of this. There needs to be more information on where these works would be appropriate and feasible, how you'd go about carrying out those works, what the benefit of those works would be in terms of emissions reductions, and what the implications and impact would be for the surrounding landscape. The major project, I suppose, that we have, and it's up and running a few years now in that space, is the Re-wet project. Some farms, 12 farms in total, some in the kind of Kerry-Limerick area, the border area between those two counties, mostly in the Midlands. So you have, North Tipperary on the Offaly border, and predominantly in around Offaly and Laois in those counties. The main objective is to look at re-wetting, looking at raising the water table. If we try and raise the water table, what is the effect on these soils? First of all, what's the current drainage status? What's the starting point in these soils, and how do we control the water table? Can we control the water table? I suppose, for more importantly, what's the cost and what's the impact? And if we look at the image there of the map you're seeing on the right, is Clara Bog. The town of Clara is just kind of chopped out of the top right-hand corner of that image. And you're seeing two farms there in terms of the red dot being the farmyard, the blue dot being the peat grassland, and they're generally on the fringes of large peat areas, peatland areas. So you're moving from mineral grassland into transition zones and into industrial cutover or peatland areas in most cases. So it's that areas around the fringes of larger peatlands. And that's a diagram, I suppose, illustrating that point. Is taken from Hammond, from an old survey that was done on peatlands. But you're seeing that again from the left to the right, moving from mineral soils and getting into wetter mineral soils, and into shallow peats or peaty organomineral soils, into full peats once you move over 40 centimeters of organic material, and getting into fens and raised bogs across as you move from right to left there. So we're in that transition where the farmed peatland areas are on the fringes of larger raised bog areas. And you're seeing that there in that image, which is in County Offaly, and you're seeing there that you're moving from where the road and houses are there on the left of the image, and this is flashing through a number of different years, so you can see changing land use in some cases. But you're moving from mineral grassland down into some forestry there that you're seeing growing as the image progresses, down into domestic cutaway peat, into, on the right-hand side of the image, industrial cutover Bord-na-Mona, under Bord-na-Mona management. So you're seeing there, over the course of a fairly small scale, we're not talking about, if you scale it off the size of the dwelling houses there in the top left of the image, we're over a couple of 100 meters here. We're not over, hundreds of kilometers or anything. So yeah, you can see that transition there in practice in that particular site. We have a number of people, as I said earlier, working this project. This next few slides is coming from David O'Leary's work, who's the postdoc on the Re-wet project, but he has done a lot of work in terms of looking at remote or analysis of these areas, of these soils, looking at, in this case, gamma radiation, so airborne radiometrics, to try and identify that transition, or where the peats are, where the mineral soils are, and defining the transition between them as you move from predominantly mineral soils into predominantly peaty soils, and there's that gradation moving from one to the other. The system that he has used, there's a telesurvey that is going on in the southwest at the moment, in County Kerry. Most of the country is done at this stage. And it's a survey that was done for over the last number of years. But with that survey, there was estimates of gamma ray production. Mineral soils are a source of gamma rays, and peat soils act to block these gamma rays. So using that information, you can basically decipher where the transition between the peat soils and the mineral soils is. David has published this work in the last number of months, and if we look here at again, to locate people, you see in the top middle image, Burr, County Offaly is located there, and the yellow dots are some of the farms on the study. The Re-wet study, different classifications, some fens, some raised bogs, as we'll go through in a minute, and peat depths, quite a variation in peat depths. You can see the national land cover map in the top right, and you can see there the Irish Soil Information System map showing peat and non-peat areas. the Irish peat soil map, which is a more recent map showing peat and non-peat areas, and then David's work on the map that shows a scale classification between non-peat and peat areas. You can see that transition zones maybe more clearly and where the farms sit in those. So its work, I suppose, it's providing us more information in terms of more detail, as we'll see in the next slide or two, in terms of what these sites look like. So this is the F1 site, as it's called, on the RIWET project. You can see the satellite image in the top of the image. You can see the national land cover map, which identifies this as cultivated land, which it's not. So, you know, the resolution isn't there necessarily to pick up the exact land use in all these cases. But you can see on the sign information system, this is in a peat zone, and the peat soil map, it's between peat and non-peat. And then in the TELUS scale classification map that David O'Leary has produced, you can see quite a bit more detail there at that scale, even of where the transition from peat into non-peat is happening by that estimation method. And these are all different estimation methods. There's neither of them wrong or right, but they provide different levels of detail or different scales of detail. This is a site at Gerteen College that's included in the RIWET project also. And again, you can see a satellite image and the national land cover map on the top, and you're seeing different efforts at peat mapping or different techniques at peat mapping showing different things in the bottom three images. And what we're seeing with the bottom right image, which is the more recent mapping methodology that was developed, you're seeing, you know, what is an isolated island of peat there in a sea of mineral soils. And you're seeing there on the boundaries of that where that's transitioning back into minerals. So again, it's just a useful technique just to show that has been developed, and giving again some detail on these sites. The other work that just to highlight, and I'm sure Dave could sit here himself and present this over many hours, so I'm just giving a whistle-stop tour, but he's done a lot of work as well in terms of imagery, in terms of identifying drainage features. On this image, maybe the next image, they're a bit clearer, but on this image, you can see in the right-hand image there, so you're seeing an aerial photograph, on the left, and you're seeing on the right-hand side, you're seeing a LiDAR image or taken from a drone. And if you can see my mouse, you're seeing these linear features here, here, and here on this field, and you're seeing in the adjacent field these other linear features. So those are drainage features that are able to be picked out by drone technology. So again, in trying to look at slowing the flow from these drains or assessing the drainage status of these sites, being able to identify drainage features is hugely useful, because when you're looking at the aerial image on the left, or you're walking around this field site, those features aren't at all. You might pick up one of them or stumble across an outlet from a drain, but that level of detail isn't going to be clear, even with an army of people walking around. This is another site, and again, some of the drone imagery that's in play, and you can see in here on the left is just an aerial image, but on the right, you're seeing a digital elevation model from that drone or from some of the drone technology. And you're seeing there again quite clearly, if we flick between the two here, you're seeing on the aerial imagery there, again, those drainage features being picked up. And again, they're much easier to pick up on the image on the right-hand side than they are on the image on the left, or again from walking around the site. So I suppose the efforts then at raising the water table or blocking drains, I suppose the task was put to us to try and slow the flow out of these sites and assess the impact, as I said earlier. So there's a few photos there just showing what that looks like in practice. These are plastic sheet piles and just a timber frame supporting it and a notch here. So you're raising the water table up. Obviously, it's sitting at this level and having to flow out over this point in the middle of the photo, and similar here on the right-hand side. This is a flume structure that we use to measure flow. And again, two different sites there. But if we look at the image on the right, if you're looking up along the stream, obviously without that flume structure, the water level is, 30, 40 centimeters lower than it would be with it. And you can see where that's flowing out over that flume. So these are the kind of structures we've done to, as I said, raise the water table in the streams. Again, you can see there quite clearly in either case, there isn't like the Bordnamona scenario, there isn't surface water being stood on these soils or ponds being created on the surface. It's raising the water table in outlet drains. And similarly, again, you can see here again, I suppose, with these images, you're seeing some of the sites and the variability that we've picked up between the different sites and some of the different, I suppose, techniques that are in play in terms of trying to lift the water table in open drains. With that, then we're measuring a number of different parameters, water table depth being the key one, soil moisture, flow, discharge, what's flowing in the open drains, and rainfall, and trying to marry all that together, what's happening over the course of a month or a year or longer term in terms of what the impact is and what the status of these sites initially, and then the impact of trying to raise the water table. Lots of colourful dots in the maps there, but they're indicating, positions of wells, position of sampling points where these soils were sampled, soil moisture sensors, and so on and so on. So there's a lot of different monitoring and measurement in play at these sites. If we look at a number of these sites, then again, this is a similar image to earlier, and it's showing the map, the TELUS map that was developed on a broader scale. But you're seeing a number of different sites there identified as F1, 2, 3, 4, which are 4 fen sites, and RB1 and 2, which are raised bogs 1 and 2. And those 6 sites are, and this is work that was done by, or is being done by, Hilary Pearce, who's the PhD student on this ReWet project. These 6 sites, I suppose, have been shown to be kind of broadly representative of the wider 12 sites. So there's a focus on these at the moment in terms of looking at the drainage status. And if we go back to the previous image and drop these in, you can see, broadly speaking, in that transition where these sites are sitting. F1, for example, is, those dip wells are 2 meters deep, are fully encased in peat. F3 and F4 are broadly similar, where they're, predominantly in the peat, these wells, but they're breaking through into the subsoil, which is a mineral subsoil, and you're seeing different, there's slight differences in terms of the makeup of these sites. Some classification there, as I said, those sites are all Offaly bar RB1, which is in County Laois. You're seeing pH ranges there in some, just to give an indication. Average peat depth, I suppose, is important as well. You're ranging from 106 centimeters at F4 up to 238 centimeters at F1. So again, quite a lot of variability in all aspects of these sites. No matter what parameter you're looking at quite a bit of variability. There is no kind of standard site and a standard option in terms of management of it. There's a whole lot of differences in play. This is the kind of data then that Hilary is collecting with the help of SF Schnell and others who are out on the ground putting in the equipment to gather this data. You're seeing a lot of information in that graph, but ultimately what it's showing is water table depth. This is at the F1 site, which I forgot to label it. The F1 site. So you're seeing there 5 wells, the data from 5 wells over the course of a 12-month period from September 23 up to September 24. And the dark blue line is the average value of those. The plot on the top is the rainfall over that period, and the red line, the red dotted line, is the 30 centimeter level, which is the all important level. But you can see there quite clearly, you go on 10 different days in that year, and you're going to be at one side or other of that 30 centimeter line. And that's important to state as well. It's the average over the year that I suppose counts or that yields the classification of these sites. But there's different things happening at all times of the year, particularly on this site where it's dancing around either side of that line on average. We have this data obviously for multiple sites, and I said these 6 are broadly representative of the wider 12 sites, and you're seeing there quite clearly a lot of difference. And we've classed these, or Hilary has classed these, I suppose, into 3 broad categories there, or 3 broad behaviours, seeing F1 and F2, broadly similar in terms of water table position, F3 and F4, a deeper water table, and broadly, are exhibiting kind of similar behavior, and the 2 raised bog sites then with shallower water tables and exhibiting similar behavior again. If you look at those 12-month periods and do the average sum, you're seeing The two on the left, again, very close in terms of the average water table, 41.8 and 41.3. So those are classified as drained sites. The average of the two in the center, much higher, 70 centimeters approximately, 114 centimeters approximately. And the two on the right, the raised bogs, 12.2 and 15.7. So of the six, those two on the right would be classified as re-wetted, because the average is significantly less than 30, but is less than 30. What we've done, or what Hilary has been working on as well, is looking at average water table depth versus rainfall and seeing the response of these sites. And again, we're seeing classic differences or trends in terms of behaviors. So you're seeing for every millimeter of rainfall, you're getting a certain response on the left, a stronger response in the middle, and not a stronger response on the right, to put it in a nutshell. So you're seeing different responses in terms of how these react to rainfall events. And how they react to rainfall events, I suppose, dictates their water storage capacity. It dictates the degree to which they're manageable in terms of water table, and the degree to which, maybe groundwater is more in play than rainwater impacts, and so on. So we're picking up lots of differences in terms of how these sites are behaving. To group them broadly into the F and the RB categories, the fin and the raised bog categories, you're seeing again quite a difference there in terms of the behaviors and in terms of the impact of rainfall on water table rise. So we're trying to separate out these different sites and trying to look at trying to classify them and trying to categorize them, I suppose. Another project that's, I suppose, relatively in its infancy, but it has a lot of work done, particularly in the last 6 months, on getting off the ground, is the DTEC project. It's looking at drainage status, and it's looking at larger scale. So the re-wet project is focused generally on areas, probably less than 5 hectares, and trying to manipulate the water table over relatively small areas. Whereas this project is looking at much larger scale sites and looking at the transition between, as I said earlier, mineral soils into organomineral, into peat soils, and so on, and trying to put finer detail again in terms of the drainage status. I should mention as well, University of Galway, Trinity College Dublin, MTU, Munster Technological University out of Kerry, out of Tralee, are tied in here, and it's funded by the Department of Ag and the EPA. And it's quite a large project. There's one site. Sorry, the sites then are 3 sites that were selected, and these are sites that were formerly or that are currently in the re-wet project that we've taken on a larger scale. So these projects are, I suppose, building one on top of the other, or being stacked on top of each other. So we're building longer term data sets on these sites. So the image there on the top left is the boundary of the Kerry site, and you're seeing there on the bottom left an image showing relative peat depths, and again huge variability from 0 up to nearly 3 meters of peat, and the elevation above sea level on the image on the right. You're seeing the classification of that site again in terms of mineral and peat, the green versus the blue, and then within the peat you're seeing different depths of peat within that blue area on that site. The red lines are access roads, but again you're seeing the kind of information that's being gathered over these sites, and the image on the right then is a drone image taken looking across that site. So we're trying to marry up information collected on the ground in terms of water table depth, vegetation, the variability between the mineral and the peats, and the different depths of peat and the different water table positions with aerial imagery, and trying to marry all those elements together to try and look at across the landscape, can we estimate the status or the management or drainage status of these larger areas. A number of related projects that I just wanted to mention. Again, there's a lot of work going on in this area. The Aspen project is based and shares some sites that I've already mentioned, and is looking at the impact of water table depth again on emissions, particularly nitrous oxide. There's automated chambers there that are running around the clock that are measuring emissions and trying to refine what we know about these soils. Carbasol project again is looking at methane and carbon dioxide dynamics across a number of sites, and there's a number of different treatments in play there in terms of different water table depths and so on. Smart carbon farming is another project that's funded by Interreg that's allowing us to go out and sample these sites and collect information on soil carbon stores, again, there's a number of other projects which I haven't mentioned that are working on this question in terms of the emissions from these soils and the management of these soils. So I'm gone slightly over time, but again, I'd like to acknowledge all the contributors, and I haven't even named people because I wouldn't have a big enough slide. I've just mentioned the teams there and the related projects and my own team in terms of the Re-Wet project, and the funders and the other partners in terms of the different universities. So that's it, folks, for now. If you want to open it up to questions, I'm happy to work through those.
Lots and lots of questions coming through here. I mean, there's no doubt that this is a complex area, and we've had a number of questions coming in from people. I suppose I could come summed up around the whole scale, at what level we should be looking at in terms of is it a field level or landscape level, in terms of this re-wetting. In practice, how does this work, or how do you see this working in the future?
Yeah, well, I suppose it depends on who's looking for the information. At a policy level, there's certainly an appetite for broad scale, landscape scale imagery, like some of the stuff I showed in terms of, what can we identify. The biggest trouble with this is water table is the key metric, and without, wells and sensor arrangements and lots of data collection, water table information is hard to gather. So we're trying to use proxies for that. Can we estimate what the vegetation looks like under certain water table dynamics? Can we estimate, from different imagery what we're seeing on the ground, do a sweep with a drone that would, do probably 20 days of manpower in 2 hours, and it's trying to do it at that scale. But in terms of the management, this going forward, and if there's various different projects coming on board to try and subscribe people up to the idea of re-wetting farmland, then the farm scale information, how do we actually do this on the ground? Simple things like where do we start to hold up the water, or what level do we need to raise the water table to? What's the impact on the land in question and the neighboring land, and all those implications is a farm scale question. So depending on what you're looking at, you need different information, I suppose, at different scales.
So it's very, very site specific and tailored solutions required. Is what I'm hearing from based on the data.
Largely, yeah.
To different sites. Cathal, lots of excellent questions coming through. Lots of experts joining us as well.
Yeah, good variety. And lots of compliments, Pat, about the presentation. Really good. Several compliments there. So, but some interesting questions here coming in. Somebody's asking about maybe extensive grazing in the uplands, Pat. So out of 340,000 hectares, are the extensive upland grazing included in that?
Yeah, potentially. You've a number of different land uses in play there. But for largely for the uplands, again, unless the elements of these soils that are intensively drained and fit into that drain category would need intensive drainage and intensive levels of maintenance to get the water table down consistently below that 30 centimeters. So largely speaking, a lot of those uplands would probably fit into the re-wetted category. So the current management, or the historic management, if you want to call it, for the last 20, 30, 50 years is probably what's going to be the management going forward. There's going to be no drastic change because they're unlikely to be meeting the criteria that they're classified as drained, unless there's ongoing and intensive drainage efforts going on.
Do we know the kind of breakdown of what peat soils are in the uplands versus kind of down a bit?
I don't have to have my head, Carl, no, but there's a fair proportion of those that are in that category.
Yeah. Kind of comment here that your explanation of re-wetting is really useful, Pat. Kind of, however, farmers managing the 40% of drained peat soils may not wish to let them slip into the re-wetted category. Any comment on that?
Absolutely not. Yeah, and look, I'm not here to speak directly on the policy side of things, but anything discussions I've been involved with or have heard, stuff that's out there publicly, there is no any of this will be voluntary. There is going to be no one forced into a position where this is imposed on them. So if someone, as the point was made, if someone is not interested in moving in this direction, then there hasn't been any indications that there'll be pressure on them to do so.
And more along the same line of regulation, there's a question here: are farmers still allowed to drain and convert peatlands, wetlands, moorlands?
In terms of drainage or conversion, so there's different rules in terms of the EIA, the Environment Impact Assessment. So if you're draining a peatland, you do have to apply for screening. If it's already drained versus any untouched or virgin peatland cannot be drained under the GAIAC regulations or under the EIA. So those are for people to I suppose use their own local knowledge and their own understanding of what's peatland and what's not and what the history of it has been, and then get the appropriate applications or guidance on that.
Yeah, and for anyone wondering what EIA is, Environmental Impact Assessment.
Yeah.
Pat, a really interesting one on carbon stocks. Should we be taking baseline carbon stocks before rewetting, restoration measures to see the difference?
Yeah, and that's something that we're looking at very much so. And as I said, a number of the related projects are looking at the before and after. I suppose the changes to the emission profile or the differences between the emission profile at different water table depths. So that's something that's very much in play and needs to be done to try and classify what the impact or the changes would do to these soils.
Yeah, and very much a process-driven question here from the science side of the house. So when the water table comes up and it covers the soil each year at certain times of the year, it sequesters carbon. Someone's commenting. So is there a change when the water table rises up and down? Are you losing and sequestering in the 1 year?
Yeah, that's going to be a very site-specific one again. It depends on the site. You may not be sequestering, but you may be preventing loss if it's at the surface. It would probably need to be long-term saturated for there to be additional carbon stored. But you do have different cycles over the course of the year. You do different cycles year to year across all soil types. So depending on the level of the degree of saturation or the moisture content, you're going to have different dynamics happening. This time you take March, April 2024 versus March, April 2023, you have totally different dynamics in terms of moisture content. So soils are behaving different. All soil types are behaving slightly differently, and that follows through with these types of soils.
And we have probably a landowner here with a bit of land. It goes back to Mark's first question, I think. To have an acre up in Mayo, they're wondering, is it worth rewetting the acre?
Well, I mean, that's going to be, there is, as I said, a call now in the Climate Action Plan that there'll be 80,000 hectares moved into that rewetted category by 2030. So watch that space, I suppose, and there will be a push on to try and get people to sign up to that, again, voluntarily. But if someone is interested in such an idea, then that'll be quite feasible or quite required, I suppose, going forward.
Be practical plans just to drill into that one a little bit more to rewet, looking at an acre in isolation, or will there be cooperation required with neighbours, or how?
Yeah, and that's a good point, Mark, because that's an issue that's often raised, and it has been the issue that I suppose the predominant political issue around the Midlands, around the Bordamona sites. Will the impact of rewetting on site A impact site B being adjacent? And in the experience we've had, there hasn't ever been a call for blocking major drains or main arteries that are servicing wider landscape. If you are blocking something, it's an internal drain and it's only impacting, locally, and if there's, another landowner impacted, then it can't be done. It can't happen unless they're on board with it happening, obviously. And as I said, I stand to be corrected on those figures, but there's approximately 14 or 15,000 hectares in the under Bordamona that have already been rewetted. And if every one of those was going to impact on a neighbouring hectare, we'd certainly have heard about it by now. It's internal drains, and it's not main arteries or main waterways that you couldn't possibly. You would be contrary to the Arterial Drainage Act if that was even an idea to do something like that. So it's internal drainage and the changing or the manipulation of that, which is in question here. It's not larger water courses, and it couldn't be, because you would be imposing something on a larger group of people that aren't necessarily on board with it. So that's not in play here, or hasn't been proposed at any stage.
Much work pipe done on the ecological impact of this these changes. I presume, I suppose you're kind of reverting to nature in many places.
Not so much that in the work that I'm doing, but I know related projects. If you look at the various different DIPs up along the western seaboard in particular, they have, for the purposes, if you take the Hen Harrier project in the Kerry Limerick area, there was an element of rewetting within that project to improve biodiversity, to improve food sources for the Hen Harrier, so there's related elements there. So again, not stuff I'm directly involved with, but that certainly is a consideration with other pilot projects that are going on.
And on the water quality side of the house, Pat, were you looking at any issues around nutrient leaching or mobilization of anything when water tables raised?
Yeah, and if you take the likes of the Carbasol project and similar projects, they're looking at that. They're looking at the carbon and nitrogen dynamics. They're looking at what the different dynamics are at play when you're changing the water table, or at different water table levels. So yeah, that's an ongoing question as well. So carbon, in terms of where the water table position is, has an impact on emissions as gaseous emissions, but it also has emissions on through the water courses and carbon lost in that direction. So that's something that's been looked at also.
Bit of a comment here, and I don't think you'll be able to answer it, but I'll say it out anyway, that there is bogland out there that's not eligible for entitlements for maybe BIS payments, and there's kind of a comment saying maybe it should be.
Yeah, it's above my pay grade now, Cathal. Yeah, it's a fair comment, something that they can follow up on maybe.
Yeah. And just as regards, we talked a little bit about greenhouse gas emissions, but you are measuring on the re-wet sites, are you? And comparing the different depths?
On some of them with related projects, yeah, we're more focused on the water table depth, the soil moisture, and the discharge in terms of water. We're looking at all the water side of the question, but there's other projects associated that are measuring emissions. I mentioned there's auto samplers. Some of these sites are shared with the NASCO project, which is the National Agricultural Soil Carbon Observatory, and there's idiocovariance towers on some of these. So related projects are, but not necessarily us directly, but we're linked in with those. And that's the beauty of having shared sites, I suppose, which I mentioned for these projects and related ones.
And quite specific question here, certainly from a farmer, I'd say, is there any agronomic data or production data, when you are changing around a water table, is there loss of production, I suppose, is the concern maybe?
Yeah, that is something we're looking at. We don't have a whole lot of data there yet. Some of the sites that are in play, as I said, that the status doesn't change or hasn't changed. They were relatively wet to begin with, or they were drying out over the summer and wetting up over the winter. So it is something we're looking at, but I don't have the data to hand as we speak.
Yeah, and who manages the joining up of the actions, Pat? The effectiveness curtailed by the field versus landscape interventions.
I'm not fully following the joining up of the actions. How do you mean, Cathal?
Yeah, I suppose the effectiveness of the actual actions in the landscape drain, I suppose, goes back to one of Mark's questions at the get-go: the right measure in the right place.
Yeah, and we're looking at how far the effect of our interventions is having an effect on and we're looking at all those issues in terms of if you do something at point A, how far does that extend and what the impact is. So it's something that we're, I suppose, conscious of or trying to get a number on, and that will impact, because for every point where the water table is raised, if that's having an impact on, 100 square meters or a hectare is probably optimistic, but you know what I mean? It's going to have a very different cost element in terms of the management of this going forward.
Yeah, there's a few questions around, I suppose, looking at where the peat is, and I know you showed I think 5 or 6 different slides at how you're figuring out what amount of peat is and where it is in the landscape. And you looked at the Teagasc method, I think was the one of the projects you mentioned. Is how accurate is it, and is it ground truthed?
Yeah, so the Teagasc method was developed under the Rewet project, or part of the Rewet project, with David O'Leary, who's the postdoc, and was published this year. And David is someone you should probably have on at some stage, Cathal. But all these methods use different techniques, as I said earlier. We have, very detailed peat depth maps on these sites and where the boundary is, so that we have that element of ground truth. And we're finding, I suppose, the Teagasc map or the Teagasc method gives us more precision, I suppose, in terms of some of the boundaries versus some of the other maps. But again, all these maps have different techniques and are done at different scales, so they're not necessarily, right or wrong, but they're answering different questions, I suppose. But it has proven to be useful in terms of accuracy at that scale, that field scale.
And the drone imagery the same way that you're identifying drains. I know there's kind of 1 or 2 comments around here that could be used not just on peat soils but on mineral soils as well for identifying drains and lands. And maybe did you compare it to the OSI maps?
Yeah, it's something we could do, but yeah, absolutely. And it's the usual story. You can if you're used to looking for these features, you can walk a farm or walk a field and see a certain amount of them. But certainly in terms of bang for buck, you're getting a lot more detail when you do with the drone imagery. So yeah, certainly it could have use cases on any soil type, really.
There's a question here around, did you look at the percentage of saturated soils right up the water table on the peat soils?
The percentage of saturated
kind of
soils.
permanently, almost permanently. I know some of your slides were showing that.
Oh yeah, and again, we're looking at that in terms of the soil moisture. So we have measurements of soil moisture at most of the sites, and we have that done, by their segmented probes. So they measure soil moisture at 15 centimeters down to 1.5 meters. So you can see quite clearly then where, and we've been lucky or unlucky when we installed a lot of this equipment. It was September 22. Water tables were extremely low. It was quite wet in the back end of that year. Dry early 23, extremely wet. Then late 23, 24. We've had a dry spring. So within that 2.5 year period, there's been quite a bit of variability, and you're seeing different behaviours in soil moisture in terms of as it's wetting up or drying up at all those different depths. We're trying to relate that, or will be trying to relate that, to water table depth. So yeah, there's it's not a straightforward relationship at times, but we're digging into that. I suppose.
A broader question, just in relation to the level of expertise that's going to be required to support these future policies or schemes or programs within the country. Is there needs there for capacity building there across the sector to really build our understanding around that? I'd just be keen to get your thoughts on that, as to what sort of effort is going to be required to if this is going to be something that's going to be rolled out, which is likely to be rolled out further. I'm just thinking of the broader implications here for these types of programs.
Yeah, you're right, Mark. There is a view that, and that has been part of the discussion going on in terms of the targets that are there. What is the mechanism at community level or local level to get this off the ground? So again, I'm not to speak on policy. You're not here to speak on policy, but that would, in my view, very much need to be the case, that you would have, points of contact, people that, whether it's through the advisory service or related services, that you can see, a point of contact or someone to lead the charge in particular local areas, or have that information to hand and help people along this roadway if they're so interested, or if they're inclined in such a move. Certainly, yeah, there's a call for that, or a need for that.
It's been in the past for maybe drainage, the opposite side, maybe drainage solutions that were put in place weren't quite appropriate for the particular land area, and so I think we want to make sure that that's the opposite doesn't occur, or that people are have access to the expertise that's required, that we don't get those unintended consequences as a result. I think just based on what you're telling us today, it is quite there's a lot of knowledge and data required to make a decision in terms of the type of, or the most appropriate type of solutions for different sites. Am I overplaying that, or is
No?
that,
I mean, that's the body of work that we're involved with. There's a huge amount of variability out there within before you ever try and interfere or intervene with these sites. There's a huge amount of variability in terms of their starting point or their initial status. And we've moved from a position where everything was considered drained, which was very simplified. The position now where we have two categories is less simplified, but is still, there's much more shades of grey in that band in terms of where the starting point is for these soils, or for all the different hectares in question, and where they're starting from and where they'll go to, I suppose, is the real question. Do they move, one way or another, and how does policy manage that? So certainly there needs to be a lot of work in terms of lining that up.
I have one last question, I think.
Yeah, there's one technical question for you, Pat. I think it'd be interesting to answer. Are there actual gaseous data to support the emission factors from drained and rewetted grassland under peat, or are the 9 megaton reduction to 3.6 CO2 equivalent based on the IPCC class values only?
Yeah, so I suppose I should mention that we can't take all the credit for the changes that were made last year. There was also Alina Tova, another study that was done, for example, looking at emission factors. And there's work going on under the NASCO project that's looking at emission factors. So, those are getting closer all the time and more accurate all the time. But there's a research question there in terms of improving the accuracy of those as we go forward. So yeah, the more local information and nationally applicable information we get on board, the more accurate the information is going to be. So yeah, we're keen to contribute as best we can in terms of making those improvements in accuracy.
Okay, Pat, thank you so much for that, and thank you for sharing your expertise with us this morning. And no doubt this will be a topic we'll be hearing more and more about over the next number of months and years. So thank you for taking the time to join us this morning. Cathal, thanks so much for assisting with questions. I know we didn't get through all of the questions, and there were some very, very technical questions coming through that this morning, which maybe we might just direct directly to you, Pat, because I know they're quite detailed, so it might be the best way to handle those. So next week, we're going to be joined by Dr. Lindsay Wistons from the Organic Research Centre in the UK, and she's going to be talking to us about agroforestry and its benefits for animal health and welfare. So do join us next Friday for that talk. So thanks again for joining us.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.